So Pablo wanted to introduce everyone, so I'm gonna let him do that.
Hey, what's up? Actually, this has been like some slight confusion because I thought I was going to do this, but apparently I'm not. So I'm going to just introduce myself, and think Łukasz is and everyone else is, smart enough to introduce themselves. So I'm going to just yes. So yeah, I'm Pablo Galindo. I'm in the Python Steering Council. I'm also the 3.10 and 3.11 release managers, the best versions of Python ever. Don't use anything else; it's broken. And I work mainly on the parser, the GC, and the interpreter itself.
Hi, my name is Łukasz. I come from Poznań, very close by. I work as the developer in residence for the Python Software Foundation. These days, that means I mostly try to fix the new interactive shell that we introduced.
I'm Carol Willing. I think you know who I am from this morning. I work on async IO and docs.
I'm Viktor Stinner, part of the CAPI working group. I'm mostly working on the CAPI these days, and I'm maintaining Python for Red Hat.
My name is Hugo and Kemenade. I live in Helsinki. I'm the core developer for 3.14 and the one after that, which may or may not be 3.15.
3.26!
Hello, I'm Petr Viktorin. I work as a core dev in residence for the PSF. The role is sponsored by Bloomberg Engineering. And I try to do the stuff that the volunteers don't want to do.
You're being modest.
Hey guys, I wanted to add that EuroPython is about Python, and CPython is the main implementation, of course, and without people developing core of the CPython, there would be no EuroPython, there will be nothing here, no one else. So please, let's start with a round of applause. Okay, we have one question on Discord, but if anyone is ready to give the question right away, we are ready. And you.
So does that mean we're not doing pre-canned questions? Is that it?
Well, some of these are pre-canned.
Oh, okay.
So, should I ask my question or wait for the Discord one?
Ask your question.
Ask your question, please.
Okay. So, historically, CPython has been a very easy to read and easy to write virtual machine. Like it was kind of a property that the core developer wanted to have. But nowadays, it's moving towards more complexity, like for example with the JIT compiler and the no-GIL and free threading stuff. Do you think it could be problematic to getting more contributors in the future? And how is it affecting your contribution nowadays?
Okay, let me pick this one up. Right, I noticed this myself, that even since 2021, when I started working on this full-time, the complexity of the interpreter rose, and me really supporting PEP 703 with making the GIL optional is a big contributor to that, sure. However, Python has a lot of complexity when it comes to the breadth of its users. So you cannot ever satisfy everybody at the same time. And we've seen increasingly that for people it is very important for the performance story to be addressed, hence the JIT, right? And at the same time, people wanted scalability, hence free threading. And at the same time, there are plenty of edge cases that we're addressing one by one in little improvements to Python, and with which there is rising complexity of the implementation. And is it good? Well, obviously it is a cost, and we are aware of that. But to put things in perspective, even before all of those recent big changes, if you read through, say, Anthony Shaw's book about the CPython internals, and if you checked out the 3.9 interpreter, you would find 500,000 lines of C and another 500,000 lines of Python that constitute CPython. That is already huge. And saying, oh, that was easy to understand, is a bit of a stretch there already, right? So there was already a high bar of contribution if you wanted to start to contribute right to the C parts, to the core parts of the interpreter. Nowadays, we are more responding to, I don't know, external needs of the industry, of our users, where they expect better performance, they expect better scalability. So if we did not do those things, it would be easier for a contributor, for a potential contributor to contribute, yes. But you would have fewer of them because soon enough we would start losing users because we would not be modern enough.
So in terms of complexity, it is going to be complex when we roll out 3.14 because people are going to have to make some decisions. Does this apply to me or not? So it's not only the developer side of things, but it's the user side of things as well. And that's incumbent on us and the steering council to really shepherd that. And in terms of future developers, who knows? There might be other ways to onboard people and train people to become developers, core developers. So, or it may all change, who knows?
So also I want to add something because this question is quite good, but it appears quite a lot. There is some assumption that only like these things like the JIT compiler and the no-GIL and the adaptive interpreter being complexity. I mean, even in 3.9, have you seen how like coroutines and async generators and all that works? It's kind of like, it's not easy. It's really hard. So these things are certainly like adding more complexity, but like we recognize this, and I wanted to take the opportunity to also mention that, for instance, Edith in the faster CPython team, I think she plans to work or focus right now precisely on addressing like these kind of cleanups to ensure that everything works nicely. So for instance, the adaptive interpreter now it works and it yields some very good speed ups. But there are some parts that, because at the beginning there was a bunch of things that we needed to fix, and right now it's a bit like, maybe not the most beautiful code. So right now it could use some cleanups, and it right now I think is starting on the compiler parts of CPython just to refactor everything and clean it up. So even if indeed this is happening and what Łukasz and Karl say is true, there is some efforts as well within the core team to ensure that this is debuggable. And it's very important. Like, I want to say that it's not just like, oh, well, we have now decided that, we are going fully in complexity because that was our user wants. This is important. Like, for instance, Brand and myself spent in 3.12, like almost a week of debugging for some frame issue because PyTest was crashing. And that was really, really, really painful because the whole complexity of the new frame system, because it needed to be complex because now it's complex, but like it's faster, but now it's very difficult to debug. So like solving that and refactoring that will really help us in the future. So, and we are aware of that. So it's not just, now it's going to be all crazy, but it's just, we are leaning towards, more features than maintainability for sure, but that's the price.
Would you like to take it? Also answer? No? I had to ask people to continue standing, but we do have one or couple of interesting questions on Discord. And one question is, are there any plans to reach inbox 0 of CPython PRs? Or maybe like keep less than 1.6K open PRs?
So there were several plans to do that. I know Łukasz was the first one to try, spend a week closing issues or PRs, one of those.
Yeah, like 100 of those. And then, yeah, like, so we were about like from 1,500 at a time to 1,400 at a time. And then I focused on something else for a week, and the number was higher than when I started.
Yeah, so I did the same experiment with the same results. Yeah, so there, I don't think there is a plan that would work currently, being discussed. But if you have a plan that would work, we could try to implement it.
I have a plan that I've been whining about at language summits for years now, which is, if something's more than 4 years old, maybe it's time to close it. Because it's still resurfaceable. And, there is a cognitive load in terms of looking through everything. Hasn't been successful yet for reasons, but you know, I think it might be a good idea, or closing the things that are legacy, things that we're not even supporting anymore.
I think we have a policy in Python to keep the issues open, issues and pull requests, because there is a lot of history, a lot of discussion, and it's way more easy to find issues which are open. So the policy is to not look at the number, but try to make the information as easy to access to everybody. That's the reason why we are okay to keep big numbers in Python.
And there is another one, which is kind of the opposite, but you'll see.
They want more issues.
Yes. So what's the bottleneck of the development? Where is help needed?
Review and triage. Like that's always a place where we can use more.
Not.
Yeah, if people can help and review issues and like test something out and say that this doesn't apply anymore and it can be closed, that can help us get down from 7,000 open issues.
So one question follows from another, I guess. Let's do AV. Mike.
Hello, strangers I've never met in my life. I'm speaking with my maintainer hat on, and I don't know how aware of that, but like we are like in the beta phase of 3.13, and there's several of my projects that I cannot add and test under 3.13 because like half of the ecosystem is still broken. The Rust toolchain has been broken until very recently, or still is, I don't know. CFFI is still broken, and like, first of all, are you aware of this problem? And are there any plans to prevent the situation in the future? Because like in the past 2 releases, we got like very early betas, and there was a very little friction of getting the whole ecosystem to the new version. But I feel like this year it failed to a certain degree, and yeah, I talked to other people, and it seems like the Rust project does it, that they like testing the top Rust projects again, if they're going to break them, how much breakage there is. So basically like a bidirectional thing between the Rust project and its ecosystem. And in Python, the direction is unilateral, right? Like Stefan Benel opened a heated thread on DPO, but otherwise, like, are there any plans to do like a post-mortem of this whole thing, or yeah, that's it.
Okay, I suppose that the talk is about the C API, because...
Just to be clear, I do not want to belabor this one point or shift blame, because this can happen anytime again with something else. Like, I'm just, you know, like in abstract.
I suppose that most of the issues are coming from the C API, even if I know that there are some also issues about the Python. So the long-term plan is to move towards the limited C API and the stable ABI. And there is a work in progress in Python, in Python, in Py03, for example, to make it more easy to use it and to promote the usage of the limited C API. And I know that this release 3.13 was causing more troubles than usual, because there are changes caused by the big project like faster Python and the free threading project, and also some of the removal of the C API that I made. And we are trying to take it in account when we make changes, and we are listening to the feedback from users. For example, when I removed functions, if the removal is causing too much troubles to users, we just decided to revert the change to make sure that we get as many C extensions ready as possible for the Alpha 2 release, I think. And for Python, I know that it was made compatible in 1 week, but I don't know about the CFFI and the others. I suppose that someone has to work on that. And my team at Red Hat is working also on making everything ready. But the problem is that even if you have a fixed release, a fixed upstream, you still need to wait for a release, and sometimes the maintainers are busy with other topics.
Exhausting, I guess. Uh, so there's another one. So what are the largest factors of kind of backward compatibility that stale development of Python 4?
Python 4?
Just moving forward.
There is no Python 4.
There's never going to be Python 4. Guido said that Python 3 is a brand now, so it's it's part of the name essentially, and it really is because you invoke the interpreter saying Python 3. It's that's going to stay. And what's the backwards compatibility concerns for us? Well, so in Python we have this thing called the CE API, right? So obviously, I'm gonna. Okay, so the reason why they're laughing is that at language summits, very often we would have talks about the CPI, and very often Victor would prepare those talks, and he always starts with saying, in Python we have this thing called the CPI. Anyway, it's an inside joke anyway. But yeah, like it's obviously a big backwards compatibility concern for us, but at the same time, some of those changes that we're making right now with free threading and with the JIT and with continued efforts by the faster CPython team to introduce like a tier 1, tier 2 interpreter and so on, some of those APIs cannot survive easily. We will still keep them for a bit, but they are deprecated, later removed. And when Victor does remove them, there's some pushback sometimes when they're still in use and so on. This is a big concern, but at the same time, if we never moved, if we always kept the version of Python that you had, and at some point at a moment in time, people would be also upset that why is this thing not improving? Why is it still slow? Why is it not using all my cores? Why is it hard to use a GPU? And so on and so on. So that's the CAPI. And in terms of the library, the standard library, the old thought about how we do deprecations and removals of things that we want to change was that, oh, we're going to first say pending deprecation warning on something that we don't want to support. The next version, we're going to say deprecation warning because we don't want to support it. And then 2 versions later, we're going to remove that. We revised this as being too aggressive and too quick, especially with the annual release cycle. So now increasingly things that are deprecated and they're like, I don't know, old aliases of functions that we still have or whatnot, they're just going to be kept forever. It doesn't matter, right? But for changes that in fact, are now hurting us because of performance or whatever, there is a longer timeline. Hugo can tell more about this since he was one of the people who were fighting for not making deprecations removed so fast.
I don't think I was, but...
Yeah, that would probably be me.
Oh yeah, I'm sorry.
Yeah, so you basically described it. One drawback of this is we can't know in advance when some deprecated function starts hurting us. So things become a bit less unpredictable, and it's still better to get rid of the deprecated functions as soon as possible. But on the other hand, we should not be so aggressive. Yeah.
I mean, one of the key things is basically, I think this particular of Python and CPython, which is that historically we have basically not only exposed everything that we shouldn't have, that's kind of on us, but also the community has basically taken a lot of liberty to just reach out and say, this is mine now. And it's kind of a bit difficult sometimes because like literally every observable behavior is normally interpreted as like, a feature. We have this all the time. So there is sometimes when it's like, okay, we are removing this function and the function was documented. So yes, that is, deprecation. But sometimes like, oh, this function, if you pass a string, it kind of works and it does this weird thing, but I'm going to rely on this now. So is that technically a feature that we need to deprecate? So sometimes we need to like change that because it was never promised and then we break some users, but it's the deal. But sometimes the breakage is so big, especially when it affects Python and things like that, that we need to even back out even if it was never promised. So it's not about just like, oh, we have these functions and we need to remove them, and then it's just a matter of figuring out what is the good workflow. Is that what is even promised here is in question. So every single time there is a problem and someone says, hey, you broke our project, and it's very hard to just upgrade to Python 3.13, it's just a huge discussion about like, is this even something that we ever promised? So, and even if it's not, like, should we back out? And we take these things very seriously, and we have actually back out decisions that, it was things that were never documented, but it's just the breakage is so big that we need to back out. But on the other hand, that prevents us from moving forward. Right now, for instance, we have one that is very big. So I don't know if you follow the PEPs, but like we are changing in 3.13 the behavior of locals. So if you call locals inside a function, and that is changing because the semantics were a bit bananas before. And right now we are being formalized, but like there's weird things that you can do because you can call locals, you get a dictionary, and then you insert things in the dictionary, and now you have local variables that you didn't have before. So how is that working? Like, is that updating backwards like the local variables before? And what if you have unbound local errors? So there's a bunch of things that we are formalizing, but then the behavior of a bunch of calls like locals changes. And it breaks people. It breaks people in ways that, it's okay to be broken. Most of the time, yes, but like we don't know the effect, so it's really hard problems to solve.
So I was on the steering council when we had the Pydantic fast API kind of rollback, and we did listen to the community on that. Putting my maintainer hat, my not CPython maintainer, but Jupyter Hub binder maintainer hat on, what I want as a maintainer is good signaling of what the plans are. And, I think the documentation has gotten a lot better. I think, discourse is being much better, the PEPs, the steering council, outreach. And it is, as a maintainer of a project, it is my responsibility to make sure my project works with Python. So it's not a one-way street, it's actually a two-way street. Where it comes, and working in the scientific ecosystem, when you're working with C and C++ and other things, it is complex. And I think we're trying to reach out to those projects that are most likely to break.
So one thing about the signaling, one thing we should signal better, and I think for new stuff we are, is to make it clear what is the actual intended documented behavior and what is just an implementation detail that happens to work. And I think we're getting better at it, but of course there's existing stuff that nobody really knows what it's supposed to do. And when that breaks and people depend on it, they get broken. So another thing we should be doing more is documenting what you should do when you use this undocumented detail, and now it's breaking, right? So first we need to identify that. It's pretty hard to come up with situations where somebody's using that in unexpected ways, right? But maybe we should do more rollbacks when we learn about people using that stuff and kind of reevaluate. And there's another problem as the changes are faster. Sometimes when we break something and then new features get developed on top of that, which means to roll back, we would need to roll back lots of new features that lots of people are excited by, and that puts us in a pretty bad situation. And so, one thing I would like to see more from all of us is trying harder to identify the issues when changing anything.
And something that can help with that is if you're maintaining a project or just your own app, if you can test on the new versions like the alphas and betas and things, then that gives us early feedback, and so we actually know that it's broken and we can do something about it before it's actually released, the full release even.
One thing you get that way is we look at your. If it's open source or you share it, we can look at your code and tell you either how to migrate, and we can put that in the documentation for everybody, or we can go back and say, this is actually a valid use case, and we don't have that covered.
So as Peter said, I think we are making progress on the documentation to explain how to migrate the existing code. When we deprecate a function, we are trying to explain how to replace it with a code which is working not only on the new Python, but also on the old Python, which is a which can be quite difficult sometimes. And we are also trying to inspect the code using code search on PyPI to see which project will be impacted. And sometimes we even try to reach out this project to warn them that they are using code which are going to change.
Okay, let's do the entrance mic question.
Do you fear the bugs, or maybe the bug reports of the change to make core data structures in Python use lock-free concurrency? And like, what technical measures are you using to mitigate those? And what is the impact on extension maintainers switching to free threading builds of CPython?
So, currently for 3.13, there is already change internally that you are going to be part of, even if you're not running the experimental free-threaded Python. Some changes are not if-deft away, because they're just fundamental refactors of things that we need to do for everybody. Other changes, though, and that's most of the free-threaded Python, is only barred for the experimental build. Those experimental builds require specific builds of your third-party C extensions. So that is entirely like a mode of operation that we enable right now to see in the community whether there is interest and whether there's ability for us to run with free threads. My initial, kind of attempts at this looks like the community is interested. We are doing stuff like this like pretty successfully already. The scientific community was the first one to really just be interested in adopting things to work with free-threaded Python. We still find a lot of places in Python internally and in other third-party dependencies that are not thread safe. Those are being fixed like one by one. So you should expect that in the 3.13 series, as we are going along to 0.0, 0.1, 0.2, 0.3, there's going to be an entire group of fixes in those experimental pieces of Python. That is not going to affect people not using those experimental builds, but it's going to improve the life of people wanting to use them in 3.14 later, right? So that's why that was released in this staggered way, where this is not the experience that you're going to have like right away. So 3.13 is not going to be a small Python 4. It's going to break everything. You're still like pretty much safe in the world that you were in before, but on that same engine, on that same interpreter, we are preparing fundamental changes to make things thread safe. Some of them are pretty hard to actually find because they're rare. Some of them are hard to find because it's free threading in general is a complex area of computing. However, we have increasingly used both like expertise of people working on this and tooling like the thread sanitizer, which is running on CI right now, and it is actively finding issues that we later fix. So the situation with trace safety on internal data structures is becoming better, and we intend for essentially all APIs documented as thread safe to be thread safe. There's an open question, what about this entire group of things in the standard library that are explicitly said to not be thread safe? Like, what should we do in that case? Like, how should they be interacted with in a safe manner in a situation where you have multiple threads and now they're free running? That's an open question. That's where the experimental part comes in. I don't know if that answers your question about like bug reports on thread safety. If you do have a bug, like please report it. We will address it. In fact, me preparing for the keynote I'm giving on Friday, I found a free threading bug. I reported it, and Sam Gross just fixed it in less time than it took me to report it. So we're working on it.
Yeah, we had one note on this question, or maybe on answer, that the thing is that the panel is labeled in the schedule as beginners, so it might be very...
I know that.
Yeah, so it might be very well a good practice now to describe what GIL is and what free threading is about.
Well, all right. So we used to and still have in 3.13 inclusive that global interpreter lock that protects internal data structures of Python when you're executing Python code. It is a smart kind of technology that allows you to just use one lock to protect whatever you're doing inside internally in Python, such that even if you're executing many threads, there's only one Python instruction executing at the same time. Sometimes you can be smart and release the global interpreter lock, for example, when you are sleeping with time sleep, or you're reading something from the network, right? But those situations are relatively rare. For regular Python code, what you're going to have is a lock that allows only one thing to run at the same time, which is obviously a problem if even your phone has 10 cores. You want to be able to use all of them in a single Python program, and now you couldn't easily do it. There were workarounds. You could start up many processes with multiprocessing. You could use some of those techniques that you knew, oh, this is going to free the GIL because it's in Python and it's using a special instruction saying free the GIL in this place and so on and so on, was tricky. So now we allow in 3.13 to build a special Python version that does not turn the GIL on. It still has it internally, but turned off, so threads are running free. And then when you import NumPy, it's going to be like, oh, NumPy, is it now safe to use with rethreading? And NumPy is going to say no. So if that is the case, then the GIL is going to enable itself to protect your code, right? But NumPy, which in fact is a bad example, like it is actually reporting itself like, okay, we're good, then the GIL stays off. But then if you have another library that does not report itself as safe, and that's only C extensions, right? If you have just pure Python libraries, they're considered free-threaded, they're considered safe. But if you have any that is like, oh, I don't have this special thing set, then it's going to still enable the GIL, even if your Python is free-threaded. That means you should be relatively safe running this thing, even now in 3.13 beta, and see, okay, things are working. There are going to be bugs that actually were always there in your code, but now they're very easy to see when your pure Python things run free-threaded. So you're going to have to maybe restructure some of your code. But so far, so good. When we were testing things with free threading, turns out a lot of our existing code sort of already assumes that there's going to be thread usage because we had threading for a long time in Python, only it wasn't free-threaded for real. So it's not like we're starting from zero.
Okay. We have one question that I also need to rephrase given the latest note. What is fastest CPython project? And then the original question, what can we expect with this? What's going on there in the near future?
Mark Shannon, that is over there, should come here maybe to explain. Now you don't. Yeah, go ahead. Yeah, nice.
Okay, yeah, it's a project we started around 3.10. There was some slight improvement in 3.10. 3.11 was the big change. Pablo will tell you how many things we broke in 3.11 because he was the release manager. More than so that was most of the breakage was 3.11. That was a 20-ish% speed up, and then nothing much in 3.12 or 3.13. And we've just got the JIT compiler starting to work now, and some of the optimizations that PyPy uses. So we should expect some decent speed ups in 3.14 and 3.15.
Okay, let's do the AV make again.
Thanks. I saw in the past version of CPython a lot of increasing from the point of view of performances and cleaning of code, and I saw also some statistic in release notes. But will it be possible for the next release to also start measuring how it can be improved from the point of view on energy consumption? Because I think it's important from the environmental point of view to see how the next version of Python can be less energetic and can consume less energy than the one before. Because it's a theme I think a lot of people care about here, but I haven't seen a lot of effort in this direction. Thank you.
So I think the assumption is that if it's faster, if it lets you do the same work in less CPU time, then it's also more energy efficient. Like that, there's a direct correlation between the CPU time you use and the amount of energy you use.
Yeah, so that was a comment I was going to make too. But CPython.org, the benchmark suite that we're running, doesn't really have that dimension. That is just energy consumption. And I'm really saying this like, honestly, like we would accept somebody who knows what they're doing, like to just come in and say like, this is what you need to add for this to be supported. Since, yeah, like I had questions from like community members in the past, like, do you know how much like energy that could save or whatever? And we don't know. We don't know how to measure this reliably on a server. We don't know how to store this data so that it makes sense. So we're not saying no. We're just saying like this is not a consideration that we had in the past. And if we just naively approached it, I'm a little afraid that like it would just be, just us, doing something that isn't really that helpful. So if you do have, experience in that field, like just tell us what we could do realistically, and then we can improve it.
Yeah, and I think it's something that, climate change, it's important to address. I'm not sure that Python right now is the big, compared to like GPUs or something like that, they are far more energy inefficient. But, like they said, if there's somebody who knows how to measure it, it makes sense to measure first and then figure out, okay, do we need to optimize? If so, where and how? So thank you, good question.
Thank you. Can I say something? Yeah, go ahead, Mark.
I've given this a bit of thought. Okay, so there is unfortunately a bit of economics which basically says if you make something more efficient, it's cheaper and people use more of it. So if you make something use half as much energy, people use 3 times as much. However, I think it's a societal issue to determine how much fossil fuels we're willing to burn and how fast we burn them. And it's our job as engineers to make things more efficient so we can maintain a quality of life with less environmental impact. So yeah, faster means more efficient. So I take that, I think that's better. But yeah, without any social sort of constraints, that just means more energy used, not less, sadly.
I want to add something. This is not theoretical. This is you can actually search for this. It's called Jevons paradox, and this happened in the industrial revolution. Someone actually found a way to make steam engines, and it was like 2 times more efficient. And what they found out is that the usage of steam engines triplicated because now you can do more with the steam engines, so you can have them like more time. So you actually have more emissions. So it's just not just a matter of like making the tool faster. It's about like how the tool is used, which is a complicated problem. But yeah, Jevons paradox, very cool.
Yeah, another example of exactly the same thing is how you adding lanes to a highway like is going to create the same or worse congestion at some point.
Another example is adding AI to things that don't really need AI.
I agree.
Maybe I can also add a thought to this question, but going a little bit more technical. So if I understand correctly, currently, if you take, let's say, Windows x64 build of CPython, it will run pretty much on everything x64. But there are way more instructions in the newer versions of Intel and AMD PC processors, so intrinsics. And there are projects that can dynamically figure out if processor supports that and just start using that and smartly get better.
But this is such a complicated thing. I mean, I don't want to go super technical, but like just it's just a very hard thing to measure, because just number of instructions tells you nothing. Because like you can have, first of all, even if those are the instructions that actually execute, you can have one instruction that consumes 100 more than the others. And that is true, like AVX instructions will burn your CPU, but they are also very efficient. So you will find them like in glibc when you main copy, those are AVX instructions, and NumPy is all full of AVX instructions. And those will like really be like, those are like eating the environment, right? But then it's like you could say, oh, but like, you know, like you have like CISC and RISC, and like these are more instructions than this, and like AMD chips are normally a little better, but like it's not even true, because like in today's processors, those are just lies. Like those are not instructions that really execute, because there is this thing called microcode that are the real instructions, and who knows what is happening there. So if you just say, oh, let's run CPython on like, let's say x86 64, either Linux or Windows or whatever, and let's just count the instructions, like that tells you nothing. Not even of speed, like because you can have one instruction is 1 cycle, and like one instruction is 200 cycles, because whatever reason. And that even tells you nothing, because like if you have different caches, then you have different instructions being triggered, and in one system is going to use like vectorized instructions, and it's going to consume 3 times more energy. So we don't want to just report a nice number with a specific CPU that is 30-year-old, and it's like, oh, me, look, we are super nice and friendly. So it's just a very complicated aspects to focus on specific CPUs or instructions as a proxy for either efficiency or performance. Like you can do it, but like it's not a nice metric, because what will happen is that some reporter will go to speed.python.org and it's like, wow, Python 3.13 consumes like 2 times more instructions. Like, wow, super bad. And we don't want that, right? So we want something that is easy to read, and like people can make sense of that, and it's not ambiguous, and you don't have like to have like 3 PhDs to understand exactly what it means. It's a hard thing.
Yeah, to whoever asked the question, if you're concerned about that, then you should build your own build with Python, targeted to your particular CPU.
Yeah, I added this question just like as a follow-up, as a more technical version, and yeah, I do that. Okay, cool. Okay, let's do the entrance microphone.
Hi, can I go back to free threading for a second? I guess it's unusual as a feature because it's being released in a sort of experimental state, and almost by definition, the ecosystem is going to lag a bit behind the experimental state of Python. I guess, how worried are you about releasing something experimental and expectations management about that, and people actually using it and finding all the bugs and so forth?
Right. This is actually also kind of in flight. So the intention there is for there not to be any experimental builds when you don't explicitly ask for them, right? So when you are asking for Python 3.13, you will never get the free-threaded version unless you ask specifically for that. And for this to work, we need to make sure that all of this lands in its own directory structure and it's all like safely isolated. We're almost there. Like we are still identifying like some cases where we are still writing to the same binary. If you're installing a free-threaded Python 3.13, you're gonna have the same pip3 link, right? Like the same binary. Like that shouldn't be the case. So we're, we still have a little to go to make sure that those things are super isolated. But once they are, like literally when you're starting Python 3.13 with the free-threaded build, it says experimental free-threaded build. It's pretty explicit right there on the tin. Even on this one, you can still enable the GIL and see some of the behavior that you would have with the regular version. It's not exactly the same, since the free-threaded build necessarily due to implementation complexity at the moment disables some of the optimizations that are in the regular version. So the regular version, unless you need scaling, like might be faster, like in your benchmarks of a single-threaded Python, it's gonna be faster. However, with the free threading, we already noticed that, okay, people are interested in making sure their libraries work. So far, there are already wheels where they can be pre-release wheels for Python 3.13. So you already have a free-threaded NumPy that you can download. You don't have to build your own. It's already there for you. Just super cool to see. Clearly there's interest in the community. There are going to be libraries that we're going to wait longer time for. What you can do is, if there is a library like this and it's not marked as safe to use in free threading, but you're like, this isn't doing really anything that I think is going to break me, especially in my use. So you can still say, okay, like force the guild to be still disabled because I want to see what happens. And when you notice that, okay, it behaves perfectly fine, you can report this to the maintainer. When we did the annual release cycle for Python, there was a concern that, you know what, like, doesn't this make it that maintainers now have more versions of Python that they need to test with? And that was true, but at the same time, like, we weren't making a super radical change, plus the life cycle of Python made it such that those versions will go out of end of life at some point anyway. So that didn't really stop us from adopting the annual release cycle. With free threading, the situation is different because that is literally doubling the amount of releases, like with 3.13 and later 3.14 and later 3.15. We don't want to maintain this experimental state forever, which is why if you're interested in free threading at all, like 3.13 is the moment like where, yeah, you should go all in on this thing. And you should tell us like, this is how it doesn't work. This is how it's disappointing. This is how it did help me. Right? Because we're not going to keep free threading experimental forever, which means either of two things, right? Either it becomes integrated in the main build of Python at some point, which like no sooner than 3.15, but like it will have to be that, or we see interest of the community was actually minimal and the complexity is stopping us from some other things that would be nice to have. So, okay, experiment failed. That's the nature of experiments. Like if we knew it's going to work, we wouldn't have to make an experiment, right? So now the build is separated such that you can actually test with it. We are not really concerned that people will not going to be able to tell whether they're running a free-threaded version or not. Is that answering your question?
Mostly, I think.
I think what we might also see, I think it was Brett, when we were moving a lot of packages from 2 to 3, and there was this tracker that had like maybe the top 100 used packages, and it would say, okay, like it's not supporting 3 yet or is. And there may be something like that that organically comes out of the community to do that.
Actually, could you tell that to the mic so it's on the recording? Thanks.
Lysandros, you're wonderful.
Thank you. I'm part of a team that works on free threading, and as of this morning, there's a status tracker that lists all of the major packages and whether they have CI coverage for free threading, whether there's wheels, what's the first version that supports free threading, stuff like that. The website is py-free-threading.github.io. Yeah.
Woo!
Okay, technicalities. We have too many questions on Discord and too many, not that much time left. So if you are on Discord, react to one of those questions, and I will see what's the most popular one. And for now, let's do the question at the AV mic.
Hi, I'm Chris Lafra. I wrote a spreadsheet in Python that runs in the browser called PySheet, and I was in the WebAssembly Summit earlier this week or yesterday. And one of the things that we talked about a lot was performance. So if you deliver Python on the web, you have to first download it, and then it has to start up, and then it can render on top of WebAssembly in this complex stack. So we have Pyadite in the middle, which is CPython implementation that runs on WebAssembly. And we talked about like the common solution is to use 2 VMs. So you use MicroPython, which is 120K to download, and it starts up in 100 milliseconds, but it can barely do anything. It's a very like tiny subset of Python. It's not the official language, it's just a subset. But it's enough to build your UI, and then you start a worker that can run Pyadite, and then you do all your work there. And we talked about like how can we like make it smaller. So one of the contributors to the PyRun project was there, and they have been working on making CPython smaller, like the distribution from like 100 megabytes to like 5 megabytes by just compressing everything and recompiling and whatever. So I was wondering, can we make like something like PyScript and running Python in the web simpler if we can make CPython more modular, so that as a developer I can decide when I deploy it on the web that I don't need this package, I don't need that, I don't need this, I don't need threading, I don't need this. I just want this, the minimum subset that is a little bit more than MicroPython, but it's my own sort of configuration. And what would that entail in the architecture? Is that at all possible?
This question and idea comes up relatively regularly in the language summits. It is an attractive idea to be able to just say, now with the PyPI, now with so many deployment targets, how about we trim Python? So Python is smaller, and now people, you know, pip install whatever they want. So maybe async IO should live on PyPI, and now you just install it only if you need it, and so on and so on. The reality of the situation is that us, a team of theoretically 100 people, and then actively maybe 20 people working on Python relatively often, we are not equipped with you know, the ability to modularize Python in the way that will ensure that all the edge cases that arise from this are going to be well served. A great example of this is that you build Python using Python. And that is actually a two-step process in which you need to, at first, if you don't really have anything built yet, point at some other Python somewhere there that you have on your system to be able to run a bunch of things that we use to generate things. But after you already have your Python pre-built, we can use even this Python to, with setup UI, build the modules that you have. And when you're building all the modules, you're going to quickly discover that even very early on in the startup process of Python, we're importing like 100 libraries at the time. Like I don't now remember the exact number. Like it's fluctuates between versions, but it's for sure more than 60. So those things are already like, okay, that's the core piece of Python that you would either have to carve out, but you have to plan how to do this, or you need to assume those things are always there. And some of those might be surprising to you. Like, you know, config parser is one of those things. You cannot have Python without it. It's like, why? Any files, whatever. But yeah, it's one of those weird things. So we were thinking, like, yeah, okay, like, what if we actually move this to, you know, to PyPI and just make like ensure pip? Different standard libraries can now be downloaded, and maybe there's a default version that ships with what you want, but you can upgrade them in like in the future. So that creates this issue where even if you are a maintainer of a single library and you have dependencies, you have to be careful about the compatibility, right? About how upgrading your dependencies might break you, or you upgrading something else might break your dependencies, and so on and so on. So now with the standard library being really interconnected, there are no clear boundaries where you can just say, okay, like let's not use this part and we can just disable it. Even if you're like, I'm not interested in typing. I don't need typing. Let's remove that part. You will discover that there are different parts of Python now that rely on the fact that there is typing functionality, like including, I don't know, like there are features like data classes that don't do much with types, but you cannot use them without type annotations, and so on and so on. So tests for those data classes rely on types from typing. And so what do you do then? Right? You would have to make like an enormous amount of work for a really unclear goal. So we have this idea very often, but it's unclear what would that really get us. And if you're getting to those things that are inside the C code that you're building, that, oh, let's not build with this, let's not build with this, that is sort of if-def hell that we are in already because of free threading and because of the JIT, that if we now had this exponential complexity of more and more possibilities there, it would be very hard to maintain Python in that state.
Yep, so it's like monolith versus microservices. Basically the same problem. Yeah. Well, thanks committers for all your efforts and answering these questions. They're very insightful. Thank you.
I mean, one thing that we can do actually, I mean, it's a bit of, I understand that it's a bit frustrating if you are relying on like the fact that you need to like serve this binary to everyone and it's just keeping bigger. Like, and 313 and more will be bigger and bigger because one of the things that we are doing to make easier to maintain for us the language is that we are auto-generating more of the C code. So right now there is like used to be a lot of code that was manually written, and therefore it was full riddle back. So right now what we're doing is that we're having like Python files that generate that C code, but generated C code is very easy to generate because you just push a button and forget. So these files are ginormous. So when you compile them, the binary normally tends to be bigger. It's just that it's easier to maintain. But one thing that we can do actually is to at least track the size of the distribution. So like, in every commit, maybe on speedpython.org or I don't know, size.python.org or something like that, we can tell like, oh, this commit blow up the size by like 20%. So maybe we can be a bit more conscious of like, okay, maybe what happened here. So that we cannot promise that it's going to be smaller or that we can modelize it, but at least probably we can try to be a bit more conscious on the size if this is a concern from like the pilot folks. I don't think it's going to be like super easy to do, but like, just to have the web page and whatnot, but like that's something that we can track somewhere. It shouldn't be too hard.
Okay, so we have just a couple of minutes left. So, but there is one question that has a lot of votes. So maybe just 1 minute for every single member of the panel. Just what part of the CPython you're working on and why?
Okay, I'm working on the C API, which is like the user-facing part of the C part of the implementation, and trying to make that safer and easier to use. So that's my personal area of focus. Otherwise, I'm trying to do the stuff that volunteers don't want to touch.
I'm kind of helping out with CI and docs. I'm also planning on adopting calendar versioning for Python. So have a look at PEP 2026 and give feedback to the discourse thread. So instead of 3.15, it might be 3.26 because that's the year it'll be released in.
I'm also working on the C API, trying to make it more stable for everybody. And I'm working on the stable API and the limited C API. And I'm also maintaining the buildbots and the GitHub actions to fix the regression, to track regression, and to fix data races and memory leaks, any kind of regression.
I'm working on async IO because I like that kind of stuff, but even more importantly, I'm working on docs. And the reason is I want to see more, look at the panel, more women core developers, more diversity in the core developer community, because I think it brings different ideas and it's not an easy thing, and everybody up here are delightful human beings and we're all doing our best, but by being explicit with the documentation, it not only helps our users, but it helps contributors, and that should be a win-win.
Right.
And I wouldn't be here without Victor.
Cool. I'm also doing some of the stuff that volunteers don't want to do, but now I have 2 other people to help me with that, so no. I still like, I run some build bots. I help with keeping other build bots alive. Sometimes I struggle with keeping my own alive because Microsoft is changing things very rapidly now. It feels like I'm on Debian unstable, but it's just Windows 11. I don't know. In any case, my latest love is PyRepl. It starts with an underscore, unstable API. You can do what you want with PyRepl. It's Python now. It's very easy to contribute to. It's very easy to hack on, but it's going to probably look differently internally in 3.14. So if you depend on it, we're not going to deprecate it nicely. We're going to change it because it's underscore PyRepl. The steering council asked us, me and Pablo, to write a PEP on, okay, this is the new interactive shell. So I started on that. I'm just waiting for like a cooler number than the ones that are now like available. So just you need to get some more PEPs so that I can snatch some really nice number for that.
So I work mainly on the parser and the VM, but recently I've been like doing a lot of the error messages, like the cool error messages and all these like nice things. Thanks. I mean, like, I think my biggest feat is like to trick everyone else to do other things with me, like the PyRapple thing, and Lisandro's over there with the parser. So I think that's what I do. I just trick people into big projects, and then they are trapped, and they need to fix everything. Yeah.
Okay, I'd like to thank everyone for asking questions both on Discord and in person. Everyone answering questions, not only the panel, but also people here in the audience who jumped in and provided some answers. And let's wrap it up.